Okay, so problem 10.4. Calculate capital F, so that means the integral of f from -1 to x, so the integral of f as a function of x, right? So with x between -1 and 1 for those following functions. Okay, so all of these are going to be, if not discontinuous, at least functions that are differently defined in different intervals, right? So the integral is going to have to deal with this. Okay, so for instance, the first one, right? F, if we use the definition, is going to be minus x e to the minus x, or e to the x, when x is smaller than 0, and then x e to the minus x whenever x is greater or equal than 0. Okay, so if x is smaller than 0, then capital F is going to be the integral of from -1 to x of ft, right, dt. And in this interval, right, the function f only takes this value, so it's the integral from -1 to the x of minus x e to the x dx, right? Now this integral, we've done this 100 times before, right? This is minus, and then we have x minus 1, sorry, x minus 1 e to the x, right? And then this has to be evaluated at x and at 1, right? So this is, we could write this like 1 minus x, so this is 1 minus x e to the x, and then minus, so this is minus 1, okay? So when this is minus 1, this is 1 minus 2 e to the minus 1, right? So this is f of x if x is smaller than 0, right? If x is greater or equal than 0, then we have f is the primitive of this function, right, between -1 and x. Now between -1 and 0, this is going to be the primitive of this, and then between 0 and x is going to be the primitive of x e to the minus x, right? Now this again is 1 minus x e to the x between 0 and -1, and this one is going to be, let's see, it's going to be minus x plus 1 e to the minus x between x and 0. Okay, and now we can evaluate this thing. We have, this is when x is 0, this is 1, 1, right? And then when x is minus 1, just like before, this is minus 2 e to the minus 1. And then here we have minus x plus 1 e to the minus x, minus, so plus, when this is 0, this is 1, so plus 1, okay? So this, we can rewrite this like this. This is going to be 2 minus 2 divided by e minus x plus 1 e to the minus x. Okay, so it's interesting to notice that this is going to be a continuous function. So at 0, the value of this at 0, it's going to be 1 minus 2e minus 1, right? And this at 0 is going to be 2 minus 2e minus 1 minus, and this at 0 is 1 again, so this is 2 minus 1. So it's the same value for those both limits in a sense, right? Okay, so that's 1. Let's do part 2. So all of these are going to be the same, right? Now this is going to be x minus 1/2 when x is greater than 1/2, and this is going to be 1/2 minus x when x is smaller than 1/2, right? So now when let's take the two intervals, right? If x is smaller than 1/2, then f of x is going to be the integral between -1 and x of this function, right? 1/2 minus x dx, and this is x over 2 minus x squared over 2 between x and -1. Now when So this is x minus x squared over 2, and when this is minus 1, this is minus 1/2 minus 1/2, so minus 1. Okay. Sorry, minus 1, so plus 1. Okay. Okay, and so this is the integral for that interval, right, when between minus 1 and 1/2. When x is greater or equal than 1/2, we have that f of x is the integral between minus 1 and 1/2 of 1 over 2 minus x, and then we have plus the integral between 1/2 and x of x minus 1/2. Right, so this is going to be x minus x squared over 2 between minus 1 and 1/2, and this is going to be x squared minus x divided by 2 between x and 1/2. So now this is 1/2 minus 1/4 divided by 2 minus, and then we have minus 1 minus 1, so this is plus, this is 1 again, right, plus 1, and then this is minus x squared minus x over 2 plus let's see, this is 1/4 minus 1/2 divided by 2, right, no, sorry, this is plus and this is minus, right. So then we have, let's see, this is 1/2 minus 1/4 is 1/4 divided by 2, so it's 1/8 plus 1, and then this is 1/4 minus 1/2 is minus 1/4 plus 1/8, so this is 2/8 plus 1, so this is equal to 10 over 8, right, or is 1/4, wait a minute, yeah, this is 1/4 plus 1, so this is 5 over 4. Okay, so all of this is going to be 5 over 4. 5 over 4 plus this. Okay, part 3. This f is minus 1 if x is between minus 1 and 0, and 1 if x is between 0 and 1. Okay, so again, if x is more than 0, we have that the primitive is going to be the integral between minus 1 and x of minus 1, and this is minus x between x and minus 1, right? This is minus x plus 1, right? Right? And then if x is greater than 0, we have, this is the primitive of minus 1 between minus 1 and 0, which is 1, and then this is, let's see, plus the primitive between 0 and x of 1, so this is just x. Okay, so this is x plus 1. Okay, so this is f. There's a compound way of writing it, which is 1 plus the absolute value of x, right? Because if x is more than 0, this absolute value is minus x, and you notice x. Okay. Part 4. F is x squared whenever x is between minus 1 and 0, and x squared minus 1 whenever x is between 0 and 1. Okay, so if x is more than 0, this is part 4, f is going to be the integral between minus 1 and x of x squared. So this is x cubed over 3 between x and minus 1, x cubed over 3 plus 1/3. And then, let's see, if x is greater than 0 or equal, then f is the primitive between minus 1 and 0 of x squared plus sorry, the primitive between 0, the integral between 0 and x of x squared minus 1 dx. Right, so this is this one evaluated at 0, 1/3, and this is plus x squared over 3 minus x evaluated at x at 0. So this is just this x squared over 3 minus x. Okay, this is the integral. Let's see. 5. F is 1 if x is negative. So if x is negative, we have that the primitive is the integral between -1 and x of 1 dx. So this is just x plus 1. If x is greater than 0, we have that f is this integral evaluated at 0 plus the integral between 0 and x of x plus 1 dx. Now this is going to be 1, which is the width of the interval, and then this is going to be let's say this is x squared over 2 plus x between x and 0, so this is this. Okay. Okay. Part 6. Now we have 3 different intervals: 1 plus x between -1 and -1/2, 1/2 between -1/2 and 1/2, 1 minus x between 1/2 and 1. So let's see, if x is smaller than -1/2, then we have that f of x is the integral between -1 and x of 1 plus x. So this is x squared over 2 plus x between 0, x and -1, sorry. So this is x squared over 2 plus x minus, and then we have -1 squared, so this is 1/2 minus -1, so plus 1. In other words, plus 1/2. Now if x is between 1/2 and -1/2, we have that f is going to be this integral evaluated at -1/2, yes. So this integral, right? And then we have plus the sum of between -1/2 and x of this 1/2, right? dx. Now this evaluated at 1/2 is 1/4, so 1/8, sorry, -1/2, right? So -1/2 plus 1/2, 1/8 plus, and then we have the sum, this is x over 2 between x and -1/2, right? So this is x over 2 plus 1/4, right? So this is 3/8, right? X over 2 plus 3/8. And now if x is greater than 1/2, we have f of x is, I just wrote it, this is 1/8, right? Plus this integral evaluated at 1/2, so this is, or if you want all of this evaluated at 1/2, so this is 1/4, so 5/8, right? 5/8 plus the integral between 1/2 and x of 1 minus x dx. Now this is 5/2, and then let's see, plus the integral between, so this is x minus x squared over 2 between x and 1/2, right? So this is x minus x squared over 2 minus 1/2 minus 1/2, 1/4, 1/8. Okay, and so we have this, right? X minus x squared, and you have so this is minus plus, right? Minus 1/2 minus minus plus, yes. So you have 6/8 minus 4/8, right? So this is 2/8, 1/4. 1/4 plus x minus x squared over 2. And finally 7, we have f is the maximum of the sine of pi x over 2 and then the cosine of pi x over 2. Okay, so let me see. So when x is minus 1, this is the sine. Let me plot the sine and the cosine and see where's the sine and where's the maximum, right? If x is minus 1, the sine of minus pi over 2 is minus 1, right? So this is minus 1 and this is 1, right? So we start here and then we go like this, right? This is the sine of pi x over 2. Now the cosine of pi over x over 2 would be something like this. Cosine of minus pi will be like this, right? And then well, I didn't plot this very well, but this will do something like this, right? So they both cross when the sine and the cosine are exactly equal when their argument pi x over 2 is equal to pi over 4, right? And so that means that that x is equal to 1/2. Okay, so f is going to be the cosine of pi x over 2 whenever x is smaller than 1/2, and the sine of pi x over 2 whenever x is greater than 1/2. Now knowing this, the integral is going to be between minus 1 and x if x is smaller than 1/2 of the cosine of pi x over 2 dx. Now the integral of this is the sine of pi x over 2 between x and minus 1, so this is the sine of pi x over 2 minus, and this is 1, okay? Sorry, so yeah, so this is the integral of this, but we have to divide by pi over 2, right? Or multiple, yeah, divide by pi over 2. So this is 2 divided by pi, the sine of pi x over 2 plus 1, okay? Now if x is greater than 1/2, then we have f of x is this integral evaluated at 1/2. So this is 1, right? Plus 1, 2, 4 over pi, and then we have plus the integral between minus 1 and x of the sine of pi x over 2, right? So this is 4 over pi. Sorry, yeah, no, I made a mistake. So this evaluated at 1/2 is the sine of pi over 4, which is the square root of 2 over 2, right? So this is 2 over pi that multiplies 1 plus the square root of 2 over 2. Okay, sorry about that. And now we have that. So we have 2 over pi plus the square root of 2 over pi plus, and then we have again, or sorry, this is, well, let's say this is minus the cosine of pi x over 2 divided by pi over 2 between x and minus 1. Now the cosine at not at minus 1, sorry, the cosine at pi at 1/2. Now so this is the cosine at let's see, at 1/2 is going to be the same as the sine, so this is minus the square root of 2 over 2 minus minus plus divided by this, so this is 2 times this, and then minus at x, so this is minus 2 over pi times the cosine, right? So divided by this, this is what we have, okay, minus 2 over pi, like this. Okay, so we can say 2 over pi that multiplies 1 plus the square root of 2 minus the cosine of pi x over 2, and this is the integral in that interval.